Yeah, and it's my second time to Singapore, and yeah, and last time I also come here for the StarRocks Meetup about 1.5 years ago. Yeah, that's pretty amazing that last time we hosted the meetup at the Grab office. Yeah, and this time we hosted in Shopee office, and I found that. About 1 or 2 years before I come to Singapore, and we discussed with our customers to how to use StarRocks and how to use the first use case. At that time, I think Grab just started to evaluate StarRocks Grab side, and Shopee has their first use case just to go production, and currently we can see that Grab really large, a lot of user case, and Shopee have over 16,000 calls around in the production. Now, something changed, and I also visited all the customers and asked for what's the problem you met recently, and what we want from the StarRocks for next step. And one of the most important things come from here is come to me is that everyone puts more serious scenario into StarRocks. And that meaning, for example, customer facing is one of the use cases. Grab asked for want to put some merchant report, and Pinterest, yeah, as Heng Zhao told us, yeah, there is an ad report. That's the most important scenario because most of the revenue comes from the and also Shopee told me that one of them scenario they asked for 4 get SLA. That's crazy. Previously, we just put the 4 SLA to the OMTP system, not our system. Because the customers, we put more and more important scenario. All the customers need a better insight from the data, so they need analytics dashboard, better data engine. Yeah, that is why I bring this talk here. I just want to talk this scenario and achieving low latency with SLA, high SLA. And I summarize this kind of scenario as one word called query resilience. Yeah, yeah. There's a famous book called the anti-fraud term. Just means we can be resilient to all kinds of failure, no matter if it's the node failure, AZ failure, and maybe some data changes or some workload changes, some large query comes out and some resource changes. So we want to keep all kinds of scenario more stable, not only for StarRocks kernel. We want to keep there is no crash, no overheating, but we also want to put the latency of the query high SLA. That's why we build quite a lot of feature around this. And yeah, I discussed with the community about the roadmap 5. And in my opinion, customer facing or query resilience is most important thing in my mind. So yeah, next page. Yeah, so the first question is why low latency matters. Yeah, and it's very obvious that everyone, such as human nature, everyone wants to be the fastest. But when we talk about customer-facing scenarios, the end user really can tolerate the query exceed over 2 seconds if it's a web browser. They can't wait for their customers, and it's more business critical because for many of our customers, SaaS company, and for SaaS company, analytical is not just a simple feature; it's a whole product offer to their customers. So it's business really critical, and customers need some real-time insights and to driven some decision making, and customers. So they need real-time data corrections and also need the real-time data insights. And so for some really serious scenario, the SLA is non-negotiable because they can suffer any kind of failure. Yeah. And the next thing. So yeah, what's the challenge? So here is some challenge from low latency with high SLA query resilience problems. That first, I mentioned 4 of them here. The first is workload changes. Because even we can set the Apple query apart. Even for some customer-facing scenario, we don't have too much of a large query, but there are some incident traffic comes out. Maybe some high concurrency, maybe some data scheduling, data skew may cause some query changes. We want to keep it stable for all kinds of workloads. The second one is the query plan changes. And StarRocks has a pretty good CDO, and that is why more and more people want to use multi-table join instead of the normalization or tables. But the more with the complicated query comes, we need there's a challenge that the query plans for some cases, and optimizers may make some bad cases. We don't want this kind of bad cases comes out. And the next part is the infrastructure failures. No matter AZ failures or node failures, especially in share data architecture. All the compute node is easy to scale. We may add and remove the compute node in Kubernetes architecture, just as Shopee. And in this kind of cases, we still want to keep a high SLA latency. That's also yeah. The next part, last part is some resource computation. We still have some internal resource computation, such as compaction or some other async drops in the drive view. We want to isolate them clearly and make them won't impact our online business. Next one. Yeah, so here is some features around this thing. First, I want to talk about the low latency and then to high SLA. Yeah, low latency, we optimize our StarRocks performance every year, and actually for the benchmark improvement, sorry, I missed something. We improved the TDS by nearly 30%, 20 to 30% in the latest version to 3.4, and actually we don't want to focus on benchmark only because we focus on some real world cases more than the benchmark before. But we found that many of the customers still want to test the TDCTS at the beginning. So we optimize quite a lot. I just listed some of the features here. First one is the core-free architecture. Previously, we have a single thread for some, especially for some small instance, and we still need one call to do the scheduling work. So we removed this ruler recently, and this improved a lot of performance for all of the general scenario. And the second one, the runtime pushdown. Actually, we can support the runtime filter at the beginning of this StarRocks project, maybe 3 years before, but we continuously to improve this feature, no matter to push down under some aggregation operator, or even to some push the runtime filter to the scan layer, just a scan on. Yeah, and the next we improve a lot of operators. And for high granularity aggregation and a large table join, because we build a really detailed benchmark for all kinds of operators compared to all the state-of-art query engine, and we improve all the bad cases. And yeah, I can confidently speaking that StarRocks is still the best query engine for the open source and even for the closed source commercial query engine. We could maybe 2 or 3 times to order. Yeah, next page. Beyond the basic improvements for our query engine, and we focus more on lakehouse architecture, no matter it's iceberg, Hive, or Hive, Foodie data we improved a lot. And there are still some differences between the external table and the internal table for query side, but we improve most of them. For example, statistics is a definite problem. For internal tables, we will automatically collect all the statistics periodically. But for external table, we just make it up. And recently we can do, because external table is more, there's more table and quite a lot of table, and but we still use some mechanism to automatically detect and collect the statistics. And the second one is about some low latency dictionary. We use better low latency dictionary for all kinds of the internal and external table. And after that, this feature really improve our some of the features. And the third one is about the primary key and the foreign key constraints. For internal table, we can support it, especially for some material attribute scenario. It's quite important. It can introduce some view pooling or material attribute rewrites. We can use that, and also we can support this thing for external. And the last thing is query feedback. It's a kind of, there is another famous name called the HBO, historical based optimizer. We can automatically learn from our historical query plan and profile to know is this plan get good enough, or maybe I messed last time for the left and right table, and for the next time we can learn from the historical. Yeah. And this is a new feature for in 3.4. Next one. Yeah. Yeah. Besides the basic performance improvement features, we want to focus on how to achieve high SLA. Yeah. I separated it for several layers. The first layer is cache stability. Yeah. We want to. Yeah. If all the data cached in the local disk, I think that's not the problem. With for the data scan, but we still need to carefully to protect more hot data in the local disk. The first thing, the first method is to using cache warmup. We improved this feature from 3.2 to 3.4, and yeah, currently you can manual or create a cache warmup task to do it periodically. But as the first version, the cache warmup is still expensive. That's a problem. We work with Pinterest, and they give really good feedback and help us to improve this feature. Currently, in the latest version, we can directly warm up the data files without using the previously query select framework. That will reduce a lot of CPU usage, CPU and memory usage. We just cache up files directly. Yeah. And the second one is about the computer rapid strategy, but it's still a CelerData only feature in CelerData Cloud. But just imagine that for some really complicated, really serious scenario, even one replica cache is not enough, because if one node failure, maybe we needed to cache warm up a lot of data from external table or from the S3 remote storage. And for some special cases, we can enable the computer replica, which means we can have two replicas in data cache, and can improve the cache resilience to the failures. And the last part is the segmented LRU. It's introduced in 3.4, and just imagine that if there's a large query comes, there may be flushed quite a lot of memory, quite a lot of the cache. And we divided into two parts, eviction segment and another protection segment. Most of the hot data will resist in the protection segment, and the large query won't flash all the data. Next one. The second topic is about the query plan resilience. This is a new work, still working in progress, and we call it query plan manager. Just imagine that when we have we know that planner is very sensitive because some small changes, maybe data changes or performance upgrade or version upgrade may change some query plan. But for some, when we have a StarRocks cluster in production, we don't want our previous optimized query change. So this is the first scenario. And we improve our performance, or we improve a lot of operator every version, but they still maybe cause some, because we come into the deep water and they make some performance degradation. In some cases, we want to avoid these revealing edge cases. That's the second scenario for the QPM. And the third one is the data will changes. And maybe sometimes data changes, the statistics can catch up with the newest data. They will cause some query plan changes. That is also another root cause for the query plan changes. So we introduced a new plan fingerprint, just like SQL fingerprint to save all the previous important query. And if the query plan changes, we will compare with the last time. If we found some degradation of the performance, we will still keep the older one or the best one. That's the key concept of the QPM. Yeah. And the next one. The third question is about the workload management. And actually, we work in this area quite a lot. We have some resource group features to do some. We have resource group to do some isolation of different workloads, and we have a large query fuse function, and there we can quick fail some large queries. But recently we have advanced adaptive parallelism mechanism. And if you using StarRocks for you will mention that there's a parameter called high band DOP, degree of the parallelism, and it's already adaptive. For a large high concurrency query, the DOP will reduce to a small number. If it's a single query, the DOP maybe use half of the CPU core. And beyond that, we introduced more dynamic resource allocation method for the high concurrency query. And we may put some large query based on the resource prediction to put the query queue to reduce too much query running in the same warehouse or in the same cluster. Yeah. The second one is that we introduced a new framework for machine learning based resource estimation, and we can have our internal model for the cost prediction, because we already have some cost, CBO cost, but it's good for CBO itself to determine which is the best spend, but it's not good enough for the estimation for the query resources for the memory consumption. So we add a new framework in the open source, and each company can contribute or use their own machine learning model to do such kind of prediction, and to put the find some large query to. There are many kind of ways. If we have such kind of capability, we can put it into the queue or make it fail fast, or even to trigger auto scaling method as just you want. Yeah, and we also improve our large query decisioning method to make it easy to identify, add more metrics to identify the intensive queries or the large queries. The last part is about the task retry and the phasing scheduling for some large ETL jobs features. And one more thing I forgot to add here is just learn from the the short meeting recently. I think I should add a graceful exist feature here. Actually, this is really important for all the new, especially when you upgrade StarRocks to a higher version, and they also want to zero or near zero runtime. So we recently added a graceful exist. We can when we do the rolling upgrade, we will send a signal to graceful exist. They won't stop the process immediately, but keep the to redirect the new query to the new compute node and wait some slow query finish and then to rolling upgrade another CN compute node or backend. Yeah, that's the concept of that. So with all this kind of capability, we can have resilience to the workload changes, resilience to the cache changes, or resilience to the query plan. We can get, and with the best performance we can offer, we can finally get such kind of query resilience capability. Yeah, that's basically.